It has been requested for AP Calculus that I prove why the derivative of sine inverse of x is this monster that you see here on the right. So I will attempt to do this, even though it might mean that I make a tremendous fool of myself. Just a reminder that sine inverse of x and arcsin of x, those are identical things. So we're trying to prove this right here is true. So let's see what we can do. If we set y equal to sine inverse of x, we want to find this derivative. It wouldn't make a lot of sense for us to try to do it in its current form because we don't know how to take the derivative of sine inverse unless we use this rule that we are actually trying to prove. So let's do this. Let's take sine of both sides of the equation. On the left, that's going to give us sine of y. On the right, the sine and sine inverse cancel, and we get x. Now we should be able to take this derivative. Let's take the derivative of both sides with respect to x. Mad props to x. On the left, the derivative of sine is cosine. Inside stays the same. Then you multiply it by the derivative of the inside. The derivative of y is 1, but it's the wrong variable, implicit differentiation. So we throw on a dy over dx. The right side, the derivative of x with respect to x, is 1. Trying to get dy over dx by itself, which is the same thing as y prime. And if we do that, we're going to get 1 over cosine of y. Now this does not look anything like this. So we are a long ways away from trying to prove this. One of the things that we don't want a derivative to be in terms of the same variable. In other words, we got y's here. We don't want y's here as well. So just a reminder that we said here at the beginning that y was equal to sine inverse of x. So I'm going to replace y with sine inverse of x. This too does not look anything like what we are trying to accomplish. This seems counterproductive, but it is productive. What we need to figure out now is how to simplify cosine of sine of x. So I'm intentionally leaving some space under that. Let's say right now that sine inverse of x is some angle theta. So essentially we're saying this is cosine of some angle theta. If we can figure out what sine inverse of x is as regards to theta, then we can figure out what cosine is. This goes back to pre-calc. Give myself just a little more space here. If I solve this equation for x, I would apply sine to both sides. On the left, the sine and sine inverses cancel, and we get x. On the right, we get sine of theta. We know from right angle trig that sine of theta is equal to y over r. Now, it just so happens in this case that the length of y is x. So if we put this over 1, we are essentially saying that y is x in length and r is 1 in length. If we make a right triangle, quadrant 1, we are saying that the y length, opposite of theta, is x and that r is 1. We are trying to figure out what is cosine of this angle. So let's say this is just as a variable, let's just say it's a. Pythagorean theorem, a squared plus b squared is c squared. Don't know what a is. B is x and c is 1. If we get a by itself, we would have 1 squared, which is 1 minus x squared. So a is plus or minus the square root of the difference of 1 and x squared. We're currently in quadrant 1, so I think it's safe to assume that this is a positive A. So, to sum up what just happened, we are saying that this A right here is the square root of the difference of 1 and x squared. Therefore, cosine of theta is the adjacent leg, the square root of 1 minus x squared, over the hypotenuse, which reduces, come back up here to what I was trying to simplify, to the square root of the difference of 1 and x squared. Which then we can come back here, so we are saying that dy over dx is 1 over, we're replacing cosine of sine inverse of x with the square root of the difference of 1 and x squared. Hopefully that's helpful. Now you'll notice that the formula that we used, the x value, well, let me revisit this for a second here. Let's see, let me bring this whole thing down here. So focusing on this right here, we are saying that sine inverse of x, its derivative, is 1 over this mess. So it stands to reason, if we had a function in here, not just an x, using the chain rule, once you took the derivative of the outside, you would then multiply it by the derivative at the inside. And instead of us calling that function an f, we have been calling that function a u. So I think this may seem reasonable as a formula. Hopefully that's helpful. Hope you're enjoying your quarantine. Make sure you drink lots of soda. It's really healthy for you. Have a nice evening.